The next installment of my video lecture series for economic analysis of the law. And in this particular video, we're going to be taking a look at figure 6.3 from Cooter and Ulin's Law and Economics. And in here, what we're going to be trying to do with this video is to illustrate the relationship between precaution and the monetary damages from accidents. In particular, what we're taking a look at here is this particular line, which relates to the level of precaution that an individual takes and the monetary damages associated with accidents. So you can see here that this is negatively sloped. And what is trying to illustrate here is that the more the precaution an individual takes, the lower monetary damages will be. So for example, if this particular institution or entity or individual takes a level of precaution X0, some accidents will occur and there will be monetary damages of $0. So realize that if this individual decides, or this firm decides, that they're going to increase the level of precaution that they're going to engage in. So let me shift this line to the left. You will notice that we are moving down the dollar amount of damages that occurs. So as precaution increases, the dollar value of damages decreases. So if we decrease it, you can see here that as precaution increases X, the amount of damages is decreasing. So you can see here, if I bring those up, that as the level of precaution increases, the dollar value of damages that are incurred decreases. So I want you to realize that what that line is. Realize that the dollar losses is a function of the level of precaution. So as precaution increases, the probability of an accident decreases, therefore the dollar value of accidents is going to decline. So that's one function that you have to be aware of, the relationship between increasing precaution and decreasing monetary value of damages caused by accidents. A second component that we have to consider is the fact that if we're going to engage in precaution, it's going to cost us. If a firm is going to invest in precaution, there's going to be monetary costs associated with that investment in precaution. So that's what that line here, WX, represents, that as precaution increases, the level of X increases, the dollar cost of that precaution is going to increase. Now we simplified this and just assume that it's a constant value. But I want you to realize that those are the two major components we're going to be concerned with. The action of engaging in precaution and how that decreases the dollar value of damages caused by accidents. But also, the more we invest in precaution, the higher the cost of engaging in that precaution is. So we have to use these together in order to determine what is the optimal level of precaution for a firm or an individual or an entity to engage in. So we have to actually add these two together. These are two costs, right? The costs that when an accident occurs are monetary damages. There might be damages to property, etc. There could be lost income. A person could be maimed, etc. We have to include those, but we also have to include the cost of engaging in that precaution. So what we are doing is adding those two components together to get the expected social cost. So realize that in this analysis, we have to add both of these costs together, the cost of actually the accidents occurring and the cost of trying to prevent those accidents. So if you see there, the expected social cost there, ESC, is WX plus the probability of an accident occurring given the level of precaution that an individual engages in. So all this line here is just the summation of these two lines below it. So we have to take a look at both sides of the coin. We have to take a look at, yes, as we engage in precaution, the cost of accidents is going to decrease, but we're facing increasing costs the more we invest in precaution. What is going to be the optimal level of investment in precaution for this particular firm? And it's going to be where the expected social cost reaches a minimum. Here we can see that we have X star, which represents the minimum of the expected social cost curve. In essence, what we are doing, or exactly what we're doing, is we're setting the marginal social cost, the cost of investing in one additional unit of precaution, and setting that equal to the marginal social benefit, i.e. the decreased accidents and the decreased costs of those accidents. So this particular figure makes sure that you understand that when an individual or firm is investing in precaution, when it invests in precaution, the probability of accidents decrease when it increases the level of precaution, but it faces increasing costs while investing in that precaution. So we have to add both of those together. The social cost of the accidents themselves, which is a decreasing function of precaution, but we have to also add in the cost of the investment in precaution. For example, a trucking firm might place a limiter on the engines of their large trucks so that they can't go above a certain speed. Or they might invest in newer technology in braking so that the trucks themselves can brake more efficiently, they can brake faster, so less accidents will occur. So you have to include both of those components. The cost of the accidents, again, as I said, which is a decreasing function of the level of precaution, but also the fact that we're going to face increasing costs as we invest in more caution. So we have to make sure we account for both of those costs, the cost of the accidents and the cost of the precaution. So that is the expected social cost. And the reason why it's expected is, if you notice here, we have a probability. The probability of an accident is a function of precaution. So the reason why it's expected social cost is because the fact that there's a probability that an accident will occur, and this probability is decreasing as we engage in more precaution. So realize that point there where X star occurs is where the marginal social cost of investing in additional precaution is exactly equal to the decrease in the dollar value of accidents that occur for this particular firm.